While we are highly trained professionals dealing in complex mathematical procedure, we do encourage you to try this at home, as it will hopefully enhance your understanding of Surds. So welcome back to 1 Lesson 3 Math. The learning objective of this tutorial is to be able to solve problems involving surds. If you would like to attempt the 4 questions, please pause the video now before I proceed with the solutions and the explanations. So, question 1. Write the following in the form A root B. Now, I'm going to focus on the root of 147 because it's a smaller number and it might be easier to find the highest factor that is a square number. And that's what we need to do for both numbers. Now, I'll look through my list of square numbers. You can write this down if you need to. 1, 4, 9, 16, 25, 36, 49, 64. I realise that 3 times 49 is 147, and therefore I can rewrite the root of 147 as the root of 49 times 3. Now, the reason I look for a square number that is a factor is because I can then root it. Now, I split the root of 49 times 3 into the root of 49 times the root of 3. The root of 49 is 7, so basically the root of 147 simplified is 7 root 3. Now that's a bit of a giveaway, because now 432, because we're having to write our solution in the form A root B, it looks like B is going to equal 3. So I'm consequently going to divide 432 by 3 to see what happens. I get 144. Now that's also a square number, it's 12 squared. So therefore, the root of 432 is the root of 144 times 3. Split that up into separate roots. It equals the root of 144 times the root of 3, and that is 12 root 3. So now I can subtract them, just like I would subtract 12x, take away 7x, that would be 5x. 12 root 3, take away 7 root 3 is 5 root 3, and that would be your solution. Now looking at part B, we've got root 80 minus root 45. Again, I go through my square numbers to find a factor of root 80, a factor of 80. The biggest square number that's a factor of 80 is 16. The biggest square number that is a factor of 45 is 9. Now, coincidentally, although on the Batman movies they say never believe in coincidences, both of them are multiplied by 5. Both of these square numbers that are factors are multiplied by 5 to make that number. So we have the root of 16 times 5 minus the root of 9 times 5. So now we've got the square numbers, we can split them up. The root of 16 is 4, so root of 80 is basically 4 root 5. The root of 9 is 3, so the root of 45 can be rewritten as 3 root 5. Now we can subtract. We would write 1 root 5, but it's not polite, just like writing 1x is not polite, so we just write the answer as root 5. 4 root 5 take away 3 root 5 is root 5. And they are the solutions to question 1. Now expanding the brackets, we're going to use the FOIL strategy. So for part A, everyone likes a good part A, we're going to multiply out very carefully. 3 times 3 equals 9. That's FOIL first. 3 times root 20. Now I'm going to actually deal with the root 20 separately because I can simplify that. Root 20, I'm looking for the biggest square number that is a factor. It's 4, so therefore root 20 is 4 root 4 times 5. Then I can do the root of 4, so root 20 simplifies to 2 root 5. So 3 times 2 root 5 is 6 root 5, and that's our next part of the expansion. Root 5 times by 3 is 3 root 5. And then finally, I'm going to actually just do root 5 times root 20, which is the root of 100. You can identify that as 10. To simplify, we then get 9. 6 root 5 plus 3 root 5 is 9 root 5. 9 plus 10 is 19, so we have 19 plus 9 root 5 as our solution. Now when you have a bracket squared, it's the bracket. So that's always something to look out for. Again, we go through the FOIL process for this. 1 times 1 is 1. 1 times root 3 is root 3. Then root 3 times 1 is again root 3. And root 3 times root 3 is root 9, which we can simplify to 3. So it becomes 1. Root 3 plus root 3 is 2 root 3 plus 3. 1 plus 3 is 4. Plus 2 root 3 is our solution. Okay? Now rationalizing the surds. This means we need to get rid of the surd on the denominator. Part A, all we need to do is multiply top and bottom to keep it equivalent by root 3. So our numerator is going to become 2 root 3. Our denominator, root 3 times by root 3 is root 9. And the root of 9 is 3. So our solution is 2 root 3 divided by root 3. When you've got an expression on the bottom, we need to multiply by the negative version. Or if you've got a negative expression, then you'd multiply by the positive version. What I mean by that is for part B, we are going to multiply top and bottom by 3 minus root 2. And this will help us eliminate the root on the bottom. You'll see how this works. So because it's 3 plus root 2, we're multiplying top and bottom by 3 minus root 2. I'm going to put brackets around it on the denominator. If it had been 3 minus root 2, we would multiply by 3 plus root 2 top and bottom. So we're going to multiply out. Numerator is straightforward. 5 times 3 is 15. 5 times minus root 2 is minus 5 root 2. The denominator, 3 times 3 is 9. 3 times minus root 2 is minus 3 root 2. And then you'll see plus root 2 times by 3 is plus 3 root 2. And plus root 2 times minus root 2 is minus root 4, which we can deal with. So the minus 3 root 2 and the plus 3 root 2 cancel. The root of 4 is 2, so 9 minus 2 is 7. That's our denominator. And we can't go any further than that because it doesn't simplify. We've eliminated the minus 3 root 2 with the plus 3 root 2. So that would be our solution, and it is rationalized because we no longer have a surd as part of the denominator. Question 4 says find x in surd form. Now we have a right-angled triangle here involving all 3 sides. And what we're going to do is we're going to apply Pythagoras' theorem. So ABC squared 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 plus equals. So I'm going to label my triangle accordingly. C is the longest side, the hypotenuse. B and A are interchangeable, so I'm labeling them like that. Now I'm going to now work out B squared. So I'm going to square 3 plus root 5. That's going to be the bracket, and multiplying out we get 9 plus 3 root 5 plus 3 root 5 plus root 25, similar to how we've done in the other questions. The root of 25 is 5, so 9 plus 5 is 14. 3 root 5 plus 3 root 5 is 6 root 5, so we've worked out B squared. Now I'm going to work out C squared. Again, it's going to be the bracket. That gives me root 3 times by root 3 is root 9. Root 3 times by root 15 is root 45. Root 15 times by root 3 is root 45. And root 15 times by root 15 is root 225. The root 9 and the root 225 simplify to 3 and 15 respectively. Now the root of 45, you can see back on question 1 that we've dealt with that, and the root of 45 can be simplified to 3 root 5. So basically we've got 3 plus 3 root 5 plus 3 root 5 plus 15. That simplifies to 18 plus 6 root 5. So now we've got B squared and C squared. We can put them back into Pythagoras. So we've got A squared plus 14 plus 6 root 5 equals 18 plus 6 root 5. We can cancel the 6 root 5 on both sides. We've now got A squared plus 14 equals 18. We take away the 14 from both sides. So we have a squared equals, now that should say 4, there's a mistake there, but a squared, yep, I've corrected it. So a squared equals 4, and therefore a in surd form is going to be the root of 4, which obviously is 2. So I hope this has been a useful tutorial on surds. Please subscribe to the page if you haven't already. Hasta la pizza, arrivederci, so long, goodbye. We will see you next time.